You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. Let's start answering this question by first going back to the idea of the angle pi over 6, because this is the foundation of our angle here, arc 5 pi over 6. We know that this is equal to 30 degrees. And we already have a specific coordinate for pi over 6. Why do we return to this? Because this will be used to also solve for the coordinate of 5 pi over 6. Our pi over 6 can be illustrated using this given unit circle. We have here this, of course, we have positive, so we'll be moving counterclockwise from 0 to here, pi. Okay? Let's divide this pi into 6 equal parts. So we'll have here 1, 2, 3, 4. Of course, this will be the division. So we have 1, 2, 3, 4, 5, 6. 6 pi over 6 is just pi itself. So the terminal point of 5 pi over 6 is 1, 2, 3, 4, 5. It's here. Okay? We know that the point or the coordinate of pi over 6 is somewhere here. Okay? So that's actually square root of 3 over 2 and 1/2. That's 4 pi over 6 alone. But for the coordinate of our 5 pi over 6 will depend on the location of its terminal point. Take note, we'll be using the same figures here, square root of 3 over 2 and 1/2, but we are not yet done because we are going to look at the sign. The location of our 5 pi over 6 is at quadrant 2, where our x should be negative and our y is still positive. Hence, this would be the correct coordinate of the terminal point at 5 pi over 6. With this now in hand, we can now start working on the first three trigonometric function of 5 pi over 6. And let's start with cosine. The cosine is very simple. You take the x value of your coordinate, of your terminal point. So it's just equal to negative square root of 3 halves. That's it. Okay? Our sine will take charge of the y. So we have sine 5 pi over 6. That's equal to our y value here, which is equal to 1 over 2 or 1/2. Once we are done with these two, we can now solve for the tangent, the third trigonometric function of 5 pi over 6, because tangent is the ratio of sine, let's do it like this, sine 5 pi over 6, and you have here cosine 5 pi over 6. So we simply plug in the values already identified earlier. Our sine is 1/2. Our cosine is negative square root of 3. I'm gonna place the negative on your numerator over 2. Okay. To finalize the result here, take note we are dividing fractions now. So we'll be using here the keep, change, flip method. So we keep our numerator, our first fraction. Instead of division, we'll have multiplication. And we flip this or reciprocate our denominator. You have here 2 over negative square root of 3, just like that. So after this, we can now cancel 2 and 2. And since we have 1 on our numerator, and I'll be placing the negative sign on our numerator because it's easier for us to have that. You can move this negative sign here at the bottom or denominator, numerator, or even in the middle. I'm just placing it in our numerator, and our denominator is square root of 3 here. So this is now the tangent of 5 pi over 6. But we also need to rationalize this, by the way. We had that lesson before that we do not accept answers with radical expressions on our denominator. So we're going to multiply a certain radical expression here such that when multiplying to square root of 3, the square root symbol will be removed. And that's actually 3 here. Okay? Square root of 3 times square root of 3 is square root of 9, which is just equal to 3. Hence, no more radical expressions, or we already rationalize our denominator because these are irrational numbers. But to make sure that the item we are multiplying to that is not changing the actual result, this should also be equal to 1. Okay, that's just equal to 1. To make this equal to 1, we know that for a fraction to be equal to 1, and aside from 0 over 0, okay, this should be the numerator should have the same value of your denominator. Hence, negative 1 times square root of 3 is negative square root of 3. And this is our tangent. 5 pi over 6. So we are done with the first 3. The next 3 will just be anchored on the idea that they are actually reciprocals of the first 3. You don't need to memorize their structures like this. You just need to understand that, say for example, for cotangent 5 pi over 6, this is just the reciprocal of our tangent. Tangent 5 pi over 6. Our tangent is this, okay? This is our tangent, so we'll just simply reciprocate it. But I'm going to teach you a technique here to make it even shorter. Actually, this is actually already as acceptable earlier. It's just that we rationalized it, right? The point here is, if this is our given, of course, you will have 1 over negative square root of 3 over 3. When you flip that later, the radical expression will be placed on our denominator because this is 1 over 1. You will have here 1 over 1, keep change flip method, 3 over negative square root of 3, right? This means the square root will still appear on the denominator and it will just rationalize further. That's still great. But here I'm gonna teach you one technique here which is very easy. Instead of using this, which is already correct, we'll be using this. Because we'll be flipping that anyway. You have 1 over negative 1 over square root of 3. So this could be 1 over 1. That's the value of 1. So keep change flip method. 1 over 1 times, we flip this. And once you flip that, your square root of 3 will now appear on our numerator and negative 1 will be placed here. See? We don't need to rationalize it. But then again, if you're going to use this item and use the keep change method here and then rationalize, we'll still end up with the same result as this. The value here is, I'm going to place negative here, square root of 3. Because they're all just equal to 1. So that's for cotangent. Let's proceed to second. Our second of 5 pi over 6 is equal to the reciprocal of our cosine. 1 over our cosine 5 pi over 6, which is actually 1 over, you will have again negative square root of 3 over 2. Now for this time, we'll be rationalizing because we don't have other options just like tangent to cotangent. This is the method. For this 1 over 1, keep change flip method. Just 1 over 1, change the operation to multiplication. You flip that, 2 over negative square root of 3, right? Okay. And then we have here, so we'll just have negative on our numerator, 2 over square root of 3 here. Okay? If you don't want to really reach the keep change sweep method, simply automatically reciprocate them. It won't matter. You will have the same result. But the point here is we will just multiply this with square root of 3 over square root of 3 as well to rationalize our denominator. Hence, our denominator will just be rational 3 because that's square root of 9. And our numerator is just the product of negative 2 and square root of 3. Let's have the last one. Cosecant 5 pi over 6, which is the reciprocal of our sine. So you have sine 5 pi over 6. Our sine is already 1/2. You can automatically reciprocate that. I'm just going to show you here similar steps. 1 over 1. Sorry for the spaces. You will have here 1 over 1 times reciprocate our denominator 2 over 1, which is just equal to 2, or simply again reciprocate this 1/2. The reciprocal of 1/2 is just 2. So these are now the 6 trigonometric functions. You have cosine, sine, tangent, cotangent, secant, and cosecant of the arc 5 pi over 6, which can be found in the second quadrant. Again, identify the correct coordinates first before applying the rest. Thank you for watching.